Daisy chaining duplex outlets is permitted by the National Electrical Code. There are two acceptable methods for wiring these outlets. One method involves using a pigtail. The other method is to connect the incoming and outgoing wires to separate screw terminals on the outlet. Both wiring methods are compliant with the electrical code. When done correctly, both wiring methods are equally safe. However, the pigtail method is considered slightly safer because it reduces the chance of accidental disconnection of the outgoing wire, which could create an electrical hazard. Also, the pigtail method allows for easier wire identification and troubleshooting in the future. Although daisy chaining is allowed by code, it is not recommended as the best practice. Firstly, it can create a voltage drop as the current passes through multiple outlets. Secondly, it can make it difficult to isolate individual outlets for maintenance or troubleshooting. Thirdly, it can lead to clutter and confusion in the electrical box. If possible, it is better to run separate circuits to each outlet. When dealing with electrical wiring, safety is paramount. Ensure power is disconnected before working on any electrical components. Use appropriate personal protective equipment. Follow all applicable electrical codes and regulations. When connecting wires to screw terminals, ensure the wires are properly stripped. Make sure the wire is making good contact with the terminal. Tighten the screws securely, but avoid over-tightening, which can damage the wires or the terminal. When using wire connectors, select the correct size and type of connector for the number and gauge of wires being joined. Twist the wires together tightly before applying the connector. Ensure the connector is securely fastened. When working with electrical boxes, ensure the box is properly grounded. Use the correct type of box for the application. The box should be large enough to accommodate all the wires and devices without overcrowding. When running wires through walls or ceilings, protect them with conduit or cable protectors. Avoid running wires where they could be damaged by nails, screws, or other objects. When installing outlets, make sure they are securely mounted to the electrical box. Use the correct screws or fasteners. The outlet should be flush with the wall surface. Inspect the wiring regularly for signs of damage or wear. If you notice any problems such as frayed wires, loose connections, or cracked insulation, repair or replace the wiring immediately. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The electrician will be able to ensure that the wiring is done safely and correctly. Voltage drop is a concern when daisy chaining outlets. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. The longer the conductor and the higher the current, the greater the voltage drop. Excessive voltage drop can cause appliances to malfunction or not work at all. To minimize voltage drop when daisy chaining outlets, use the correct size wire for the circuit. The size of the wire is determined by the amperage of the circuit and the length of the run. Refer to the National Electrical Code tables for guidance on wire sizing. Also, avoid long runs of wire between outlets. The shorter the run, the less voltage drop there will be. Consider using a larger size wire for long runs. A larger wire will have less resistance and will therefore reduce voltage drop. When troubleshooting electrical problems, it is important to be able to isolate individual outlets. When outlets are daisy-chained, it can be difficult to determine which outlet is causing the problem. By running separate circuits to each outlet, you can easily isolate the faulty outlet. Also, daisy chaining can lead to clutter and confusion in the electrical box. When multiple wires are connected to the same terminals, it can be difficult to keep the box organized. By running separate circuits to each outlet, you can reduce the amount of wiring in the box. This will make it easier to work on the wiring in the future. When deciding whether to daisy chain outlets or run separate circuits, consider the following factors: the amperage of the circuit, the length of the run, the number of outlets on the circuit, the potential for voltage drop, the ease of troubleshooting, the amount of clutter in the electrical box. Based on these factors, you can determine which wiring method is best for your particular application. Remember to always follow all applicable electrical codes and regulations. If you are unsure about any aspect of electrical wiring, hire a qualified electrician to do the work. The electrician will be able to ensure that the wiring is done safely and correctly. Understanding the National Electrical Code is crucial for safe electrical installations. The NEC provides guidelines and requirements for electrical wiring, equipment, and systems. Compliance with the NEC is essential to prevent electrical hazards and ensure the safety of people and property. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to consult the NEC for specific requirements related to your electrical project. Overcurrent protection is an important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of electricity. This prevents the wiring from overheating and potentially causing a fire. The size of the overcurrent protection device must be matched to the amperage of the circuit. Using an overcurrent protection device that is too large can allow excessive current to flow, potentially damaging the wiring. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device. This prevents electrical shock hazards. All electrical equipment and systems must be properly grounded. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. The grounding electrode must be properly sized and installed according to the NEC. In addition to the NEC, there may be local electrical codes and regulations that you must follow. Check with your local building department to determine the specific requirements in your area. Electrical work can be dangerous, so it is important to take precautions to protect yourself from electrical hazards. Always disconnect the power before working on any electrical equipment or wiring. Use insulated tools. Wear rubber gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The electrician will be able to ensure that the wiring is done safely and correctly. Remember that electrical codes and best practices are in place for a reason. They are designed to protect people and property from electrical hazards. By following these codes and practices, you can help ensure the safety of your electrical installations. If you have any questions about electrical wiring or safety, consult a qualified electrician. They will be able to provide you with expert advice and guidance. Also, it is crucial to note that electrical codes can vary from jurisdiction to jurisdiction, so always consult the local electrical code in your area. Local electrical codes may have additional requirements or restrictions that are not included in the NEC. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult a qualified electrician before performing any electrical work. Working with electricity can be dangerous and should only be done by qualified individuals. When dealing with electrical outlets, it is important to understand the different types of outlets and their applications. Duplex outlets are the most common type of outlet and provide 2 receptacles for plugging in electrical devices. Ground fault circuit interrupter (GFCI) outlets are designed to protect against electrical shock hazards. GFCI outlets are required in wet or damp locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupter (FSI) outlets are designed to protect against electrical fires. FSI outlets are required in bedrooms and other areas where electrical fires are more likely to occur. When installing outlets, it is important to use the correct type of outlet for the application. Using the wrong type of outlet can create a safety hazard. Also, ensure that the outlet is properly grounded. A properly grounded outlet will help to protect against electrical shock hazards. When replacing an existing outlet, it is important to match the voltage and amperage rating of the new outlet to the existing outlet. Using an outlet with a different voltage or amperage rating can damage the electrical system or create a safety hazard. Always disconnect the power before replacing an outlet. Use a voltage tester to ensure that the power is off before touching any wires. When connecting the wires to the outlet, follow the wiring diagram that is included with the outlet. The wiring diagram will show you which wires to connect to which terminals. Ensure that the wires are securely connected to the terminals. Loose connections can cause the outlet to overheat or create a safety hazard. After installing the outlet, test it to make sure it is working properly. Plug a lamp or other electrical device into the outlet and turn it on. If the device does not work, check the wiring to make sure it is connected correctly. If you are not comfortable working with electricity, hire a qualified electrician to replace the outlet. The electrician will be able to ensure that the outlet is replaced safely and correctly. Remember, electrical safety is paramount. Always take precautions to protect yourself from electrical hazards. By following these guidelines, you can help ensure the safety of your electrical installations. Also, always remember to consult the latest edition of the National Electrical Code and any applicable local electrical codes for specific requirements and regulations. Electrical codes are constantly evolving to reflect new technologies and safety standards. Staying up to date on the latest codes is essential for ensuring the safety and compliance of your electrical installations. If you have any questions or concerns about electrical wiring or safety, consult a qualified electrician. They will be able to provide you with expert advice and guidance.